Okay, so this is what we're going to do today, and this is what I was able to do. Um, I just did some basic, usual things we do. That's all. Mm, so I think these ones are quite okay. They are the normal ones we do all the time, and come in. Let me close all this. I have a lot of things open here. Because of that, I'm actually having. I want to crash my machine. So as usual, I import libraries. I import the data. I do some simple analysis and some simple observations. I mean data validation, and then I do more validations, and I then move on to some EDA. I mean exploratory data analysis, and then I yeah, that was all. So I got to this particular point where I was doing masking. So guys, that's all, and we will do more. Let's start. Let's. So we have Mohammed Fozan in the building. Mohammed Fozan, welcome. You didn't miss much. We just about to start. So guys, this is what we're going to do today, and let's all get Jupyter started, and we go. So I hope by now you have your data sets in the same folder where you would open, so you won't have problems importing it. So here, always I try, you know, it's almost like it's like almost every data science project you start, you will need pandas. Our old friend pandas is here, and then we have our old friend NumPy too, and then we have our old friend Matplotlib for our data visualizations. Now, mind you, I saw something over the weekend. Someone sent me something, I mean a student, and I won't be specific. He or she um, imported Matplotlib without doing the .py plot. When you do that, fine, you won't get any problem. For example, if I do Matplotlib as PLT, I have no problem. But the whole thing is, this is not used for plotting. So if I want to, plot, if I import just Matplotlib and I want to plot, then I have to do plt.py plot and whatever I want to plot. But I don't want that. So plt.py plot, maybe I want to use pyplots. Maybe I want to plot a line, something like that. So it will be a lot of chaining. The dots will be plenty. So to avoid that, all you have to do is just, you know, always try to import using the .py plot. Don't forget that when you're doing, so you import the whole thing as PLT, so you don't do a lot of changes like dot, plenty like that. No. So that's something I would like to say. So after importing the libraries, I'm actually importing the data set, and I'm storing it in a variable called df as a short form for data frame. This is mostly used by data scientists across the world. We normally represent data frames with or store them in a variable called df. You can store it in a variable called say data. Somebody will say no, I don't want that. I want just d. Somebody will say data frame. That is up to you. But I like to do df. That is my personal thing. You can do whichever one you want. That is up to you. Now, after importing, I actually look at the head. I do the dot head to look at the first um, five observations, the first five observations here of the data frame. And then you can see we have work year, which is actually obviously year. We have experience level, which is actually, we have SE, we have MI, we have let's see here, we will see them, and we have employment type. We have employment type, that is, we have FT, we have CT and PTs and all those stuff. Then we have job title, that is actually the title of the job. We have business intelligence engineer, we have business intelligence engineer again, data manager, data scientist, and co. We have a salary, and then we also have salary converted to salaries, the currency of the salary. So this is actually 202,800 US dollars. And mind you, the salaries are yearly. That's how we charge data science. That's how we measure data science salaries. So the salary you see here is actually um, in in a year. So that is it. So if I can copy this and try. So everyone, my TA is in. TA, welcome. Um, you almost came late. So let's try to do something. I want to see the monthly salary. So if you want to see the monthly salary, you have to divide the yearly salary by 12. So this person is actually taking 16,900, US dollars in a month, right? That is a gross. That is a gross pay. So if I copy this again and I convert this to Ghana cedis, so I have to multiply it by, let's say, 10 cedis. Let's say $1 is 10 cedis. This person is actually taking 169,000 Ghana cedis in a month. That is 1.69 billion food currency, 1.69 billion. And let's just take this person who is taking 60,000. So 60,000 US dollars is actually, let's see, 60,000. By the way, if you want to do a comma, like something like, if you're an accountant, you write numbers like this, 60 then comma, those things. We don't do comma in Python, but you can use underscore. So underscore is actually the comma separator in for numbers in Python. So let's divide this by 12. So it means that this person is taking 5,000 US dollars, that's gross pay in a month. And then if we multiply this by 10 cities again, 50,000. So this person is taking 50,000 Ghana cedis in a month. It's like I don't know, I think maybe an MP or maybe finance minister or something like that. I don't know why. So I just wanted you to understand. And then now you can see that here we have salary in USD. So salary in US dollars. So we try to convert this into US dollars. So if it is already in US dollars, you will see it's same. But when we see this one, you see this one is in Great um, Pounds, right? GBP is Great Britain or British, whatever the pound. So this, uh, um, obviously pounds I think is the highest currency in Europe, right? So it's higher than dollars, and then it's higher than the dollars, obviously. So 60,000 pounds is actually 73,824 um, dollars. And then this one too is in pounds. You can see it is converted to dollars here, something like that. And then when we come to the employee residence, that is where the person is actually staying and working. And then we want to see if the person has um, remote ratio. So the number of times the person that the work has maybe remote ratio. Maybe do you have a particular time you don't go to the office? Maybe you work from home. So for my work, for instance, I have 100% remote. It's a 100% remote job. So I just stay in my room and then work. So that is what the remote ratio. Remote ratio is kinda how many days you go to the office as compared to how many days you don't go. So company location, where is the company located? And then company size, L for large, M for medium, S for small. Now let's look at the what do you call it? The shape of the data. So we can just do, since the data is stored in the variable, data frame is called df. So I can do data dot shape, and then you can see that we have 7974 observations, that is rows, and then we have 11 features or variables or columns. So I wanted to style it up a bit, and then I used the formatted print to do that. So if you want to do that, all you have to do is to just first call the print, and then I do the thing, and I set the data set as. Then if you want to introduce any foreign variable, like any foreign thing like a variable or anything, you put it in a curly bracket. Then you say the sorry. So I know the person who is doing me this. Person- It's actually Jonathan who did that. Jonathan, the devil is a liar, right? The devil is a liar. Yeah, but then today we will do the class. So um, I was actually doing the formatted print. So when you do the DF dot, the last time I showed you guys this, if you do the DF with shape, you see you get a tuple, and for you to access it, maybe a tuple, a particular element of a tuple, you use the. So if you want to access the first one, you do that. So we use the same ideology. So the first one is actually the number of rows. So I will only say that. Let me just copy this. You have to be lazy sometimes. So df dot will have two dfs. So if I do this, I get the number of rows. So I'll say okay, row, and as- instead of 0, I do 1 for the second item. So I say features. Let me see variables. Oh, literal meaning. Literal means, and I'll get exactly what I have here. So that's how we do the formatted print. If you want to know more, um, you can just play around it, and then you are good to go. Yeah. And then to So now after that, I do the info, the info to know, to get more information about. So it's a data validation process. I'm actually trying to validate to see if everything is in place. So you can see we have 11, actually indeed we have 11 variables, even said here, we have 11 columns, and then the first one is work here, which has no missing value. We can see that all of them are intact. So far, we've not had any missing value in all the two data sets we've done. But the next one we do, I'll intentionally omit a lot of them inside. Then we do a lot of data cleaning. Yeah. So we can also see a data type which is int. Now you ask yourself, so work here. When we come here, we can see that work here is actually a year. So is it in the right data type? Years should be integers because you cannot have 2023.5 or 2023.2. So we have integers, whole numbers: 2020, 2021, 2022, 2018, 1944, my date of birth, and then all those ones. So you should expect the data type of the work year or the year to be what? Integer. So it is true. That is good. It is the right data frame. Now when we come here, experience level. When we come here, we can see the experience level has things like SE for senior, MI for mid-level. So it is actually words. So since they are words, they should be objects, right? They are strings, so objects. So it is true. Employment type 2 has FT for full time, PT for part time, and all those stuff. So since it is this, it should also be object. When we come here, this should also be object, and we expect all salary, the salary to be a float. Salary should be actually a float, but here it is in integer. Why? Because they round everything, you know, to the something like that. So let me admit this guy. So Bakari Siddiq is joining. Welcome, Bakari Siddiq. So back to what I was saying. So we can kind of, do inspections and see that all the data frames are actually, or all the variables are in their right, data types. So let's say we've done company size. We can see that company size has L, M, and then so it is actually supposed to be object, and indeed it is object. So when in the actual data science project, always make sure you do your inspections, to see that not only not only that they are in this, or they are intact, or maybe they are missing values, but also whether or not they are in their right data types. And if they are not, then you think of um, putting them in their right data type, and those are all part of the data cleaning processes. Yeah. So we've done the inspection here. Now let's do more advanced data validation. And what I mean by validation is, when we say you are validating, or data validation is just like validating anything. So when you go and buy something, you check. Let's say you go and buy Camot, you just pick it, and you look for the expiry date to see whether it is expired or not. So it's more like you are checking to see whether everything is in place. So that is a data validation. So all these we do in here, all these ones are all validation, data validation, looking for looking at the shape of the data frame, looking at the info. All those ones are actually data validation. So let me just even push this one up a bit. Yeah. So the data validation come in. So we've done some data validation, but now let's pick the columns one at a time and then explore them to see whether they are actually what you know what they mean. So we're going to pick them, and then we see whether all of them actually have what they are in. So the data dictionary I gave you is actually giving you an in-depth, um, definitions and kind of like explanations about about the data sets, and then its variables. So when we go there, we can see that the work here. I'm not going to open it to you because all of us have it. You can verify when you own. Whilst I'm doing, you can verify. So that is how it is. I'm trying to prepare you guys like how we work in the corporate world. So if you're working for somebody, the person will give you what we call data dictionary. That is what the PDF folder in the listing actually does. So, or that's what it is. So it gives you explanation of the data, each variable, what it means, and what is actually entails in it, what is entailed rather in it. So if you don't understand anything, or if you don't understand anything about the data, you can go in there, and then you go to the data dictionary, and then you just look into it, and then you would understand. That is it. If you don't understand, then you call the client, or maybe the boss you're working for, or something like that. Then you tell the person, report, um, the the problem, yeah, the case to the person. So more like you are troubleshooting. So you troubleshoot, and then there will be a help. Yeah. So when we look at the work here, we're actually going to pick almost all of them, and then explore them further to see what they entail, and then to see whether they are actually, fit for analysis. Sometimes you will see that the data, when you do the df.info, all of them are intact, but sometimes the missing values are not, empty. Maybe they can represent a missing entry with maybe dash or nothing, something like that. So when it happens that way, when you do the df.info, you will see that the counts are intact, but actually the they are not intact. Maybe they contain something which they are not supposed to contain. So now when we pick the experience level, if you go to data dictionary, it tells you that they have four experience level. We have the entry level, we have the mid level, we have the senior level, and then the executive level. So we have four. So we expect to have four, unique values in the experience level in the variable. So to know the unique values, maybe let me try to redo it. So um, to know the unique values in a particular variable of a data frame, we use the dot unique method. So we have to first call the particular variable, which is experience level. If I do this, you can see that okay fine. So now let's do dot unique, and it gives us the unique values we have. So you can see them in the bracket here, or in the form of list here. Sorry. So we have SE, and if you don't understand SE, you can go to the data dictionary, and then you see that SE stands for senior level, right? That is senior level, and then ME stands for mid level, and then um, and then EN stands for entry level, and then EX stands for executive level. So entry level is the like beginner level role, like we know entry level role. The mid requires maybe some, that is the mid, like more like mid senior, and then the senior level is the highest level. Most of the times they actually require more experience, years like 10 years, 20 years experience and all those things. And the executive level is mostly managerial roles, you know, managerial roles, yeah. So now we did that. Now we want to actually see, so after doing, so I can also, if I do print, it's still the same, just that the print would actually format it and give us only the list containing the items. Yeah, but if you don't do um, print, it gives you additional information. If you just call it, it gives you additional information, and then it gives you the data type. So it is telling you that the entries or the values there, these values you see here, are actually objects. They are strings, and it is obvious. We don't need Python to tell us. We know that yes, this is string, because if you don't know anything at all, we know that the values are in quotes, so they are strings, and a string is an object, right? So that is what this line is doing. Now the next line is actually the df, the dot value count. Now we know that we have um, four categories, or four different types of entries, four unique categories in the experience level variable. Now we want to know how many senior level rows are in the data frame, how many mid level, or how many entry level or executive level. So we want to know how many of each is actually in the data frame or in that particular variable. So to do that, we use the dot value count method. So instead of using or instead of doing dot unique, we just do dot value count. Um, Let me do the dots before. So value counts, not counts plural. Now, if I run this, you see what happens. You can see that senior level, that is SE, senior level rows are the most, which is 5,754. Then we have mid level rows, which is around 1,546. We have entry level rows around 429, and then executive level, which is the least 245. Now, so we have seen that clearly. Now there is one argument you can pass in here if you do normalize. That is a normalize parameter or argument. And if you set that true, now you can see that it converts them into percentages, into ratios. So we can see that um, this is 0.72, which is like 72% of the entry. So it is telling you that 72% over slightly over 72% of the entry level roles are actually um, or the jobs, about 72% of them are senior level, and then we have about 19% are actually mid level, about 0.05% are entry level, and then 0.03 for executive level. Yeah. Now we've known this. So if you set the normalize equal to true, then it gives you the proportions, the percentages. So if I multiply this by 100, if I want the actual percentages, if I multiply this by 100, then I should get, you can see 72.15 or 16. So 72.16%, this is 19%, this is 5%, this is 3%. Yeah. So that is how, that is what the value counts method does. It counts the number of values for each particular category in a data frame, and it is always useful when we have a categorical, like a variable with you know categories which are not numerical. So in our case, like in this case, we have some four groups, and then each of the observations can actually be in any of the four. Sorry, I hope you can hear me. I hope I'm not cutting. I'm not going off. I hope you can hear me. TA, can you hear from me?
Yes, I can. Yes, I can hear.
Oh, okay, that's fine. I was kind of worried. Maybe you cannot trust on the network. So thank you. So that is what the value counts does, and we're going to use it a lot. So you've had at least one method in your um, tool belt now. Now somebody will say, how do you get to know all these things? I always tell you, if you want to know anything, in data science or in machine learning or in programming, just use the help function. So I can maybe let me see if it works. If it doesn't work, I have to watch the documentation. Okay, so this doesn't work. Let me see. So this doesn't work. So if you want to, I wanted to access the doc string, the doc string here, but it doesn't work. So if you want to know much about this method, just go to the internet and then type. Go to your search browser and type um, dot value counts documentation. You click on the first link, you would have a lot to know. You have a lot more to know. Or you say you type pandas methods, and then you scroll through. You have a lot of a lot of we have millions of methods on pandas, or in pandas library, and then you can read a lot about that. So that is what I would say you can do to save yourself. Yeah, something like that. So we've now validated experience level, and we've seen that yes, indeed it contains, when we compare to what is in the data dictionary, we have exactly the same in our data frame. So we don't have any something different from that. Now let's also validate the job type. The job type, according to the data dictionary, we have the job type can be either it's a full-time role, a contract, that is CT, a part-time, or FL, which is freelance. So the same thing we did for here. We we actually do unique. We print unique so that the unique values we do the dot unique to get the unique values in here. But I did a formatted print so that I just add this unique values and colon. So I just wanted to make it nice. It's not necessary, you can just take it off. It doesn't matter. But I just wanted to decorate it for readability sake and then for learning sake. So we can see that we have exactly as in the data frame or in the data dictionary, we have FT, and in there you would know that FT stands for full time, CT is for contract, and then PT is for part time, FL for freelance. Now we all know full time roles. Full time roles are jobs like, if you're a teacher, you are a full time teacher. It means that it is something you sign a contract maybe until they sack you or until you sack them. You're going to do until you die, something like that. It doesn't necessarily mean you cannot stop the job, but it's like you are guaranteed. Like the police are working full time, government teachers are working full time, and all those ones. You are a permanent worker, something like that. Yeah. Contract, CT contract is obvious. Maybe I can give you a work and say, oh, I want you to work with me for this particular duration. For example, a typical example is NSS. So NSS is a contract. 1 year is it 8 months or something like that. So let's say 1 year. I don't know much about that. So if it is 1 year, when the 1 year ends, you cannot call yourself NSS personnel again. My TA cannot do that. She has to, move out from her office if she is not employed, you know, or if the contract is not renewed. And for part time is a job which does not require your full, day something. Maybe we all know part time you can do whilst you go to school, study, work and study, and all those things are part time. Freelancing is different from part time in this way. With part time, you sign a contract. The freelancer is like a consultant. He is on his own, and then he is there. So if you have something, you just bring it to me. I do it for you. Then you go. So maybe sometimes I freelance. I'll be there and you tell me, oh, Charlie, can you do this thing for me? I'll be like, okay, I'll take you 2,000. I'll take you one city. Then you say, okay, I'll pay me again, and then maybe probably we settle down. You can send me the thing. I send it to you. That's all. So that is freelancing. So we've seen that, and we can see that in the jobs, most of them were full-time roles, and then only a few were the others. You can see that. So what insight are we drawing from this one? It tells us that most of the data science roles are full-time roles. Most of the data science jobs are full-time jobs, and then we can see here that most of them too are between senior level and then the mid-level, which entry level is also very significant, with only a few being going to executive level, because executive level normally it requires a lot of experience, and then tech world, you know, you can have 10 maybe data scientists and then only one boss they report to. So those jobs are quite handful, right? So something like that. Now let's do some advanced, EDA. We do some advanced poetry data analysis, and I want to plot a histogram of the work years. I want to see the distribution. Now, when I did this is the data. This is a what do you call it? This is a histogram I had. Normally we know histograms to be kind of packed. The bars are, you know, to each other, but this one you can see this. It's like a bar graph. Why? Because the values in the work year are actually not continuous. They are discrete. Continuous in the sense that um, they are not what do you call it? They are not decimals. So they are actually whole numbers. So we don't have 2022.5 and all those ones. So when we come here, for instance, any value between these here, we don't have any value here. That is why that place is empty. So normally when you do this and when you have a discrete data, it's not always good to represent it in a form of histogram. So we can probably better this. So I just kept this so that I show you that, hey, to teach us a lesson. So this is what happened, and it is always good you actually kind of um, how do I kind of know and understand what particular chart is used for what scenario. So like we did last week. Yeah. Now let's kind of better this. This is not good. You cannot show this to. If I am there and you show me this chart, it means that I don't know anything. So we kind of better it here. So now let's see. We just want to do so. Even from there, we kind of let me clear this before and let's come here. So we're plotting a bar chart. Now, why are we plotting a bar chart? You can see already these are in bars, but we don't like how we cannot see whether this is 2022 or it is 2021 or something like that. So we want to plot a bar chart. Now, before we plot a bar chart, we want to actually um, output the start where the year started. The year, the start year and then the end year. So to do that, since the years are actually numeric, You know, the starting date will be the smallest, right? Because let's say if you start from 1990 to maybe date, so between 1990 and then 2023, which, if they are numbers, which one is the smallest? That is obviously where we started, 1990. Which one is the biggest? The current, right? So the same way we want to use the idea to get something. So we call the work year, and then we use a mean dot mean for minimum. So if we do that, we get a minimum, year, which is actually the start date. And then the same way when we do dot max, we get the largest date or year, which is actually the current, where it ends. So we know this. Now I'm printing. I just want to print the the start date, which is actually the minimum date, that is 2020 as we saw up here, and then the end year, which is actually the maximum year, obviously 2023 when we did. You can see here. So after doing this, now I'm doing, I am now coming to the actual, or let me redo this so that I don't confuse you guys. Right. So let me put, or let me kind of put what we did here, and then let's redo it. Now we want to, um, when we did a histogram here, we could see that the values are actually discrete. We have specific years, and years are discrete, not continuous. They are not floats, they are not decimals, they are whole numbers. So we want to do a bar plot. But now, up there we saw that if you want to know the particular values and the distribution of how many of each value are in a variable, we use the value count, value count method. So if I do df work year and I do dot value count, I'm going to get all the years. And now it is obvious, you can see that 2023 is the current. So it starts from 2020 to 2021 to 2022 through to 2023. And 2023 has the highest number of works, followed by 2022. So it's like in descending order. Yeah. Now I know this. Let me try save this in a variable called work year. It is by choice. You can choose any variable you like. For example, let me even make it unique. So WY for work year. Just doing that myself. Now I can actually, since I've actually done that, then I want to break the codes down um, so that we understand. I know some of us have started going confused. So now let's try to plot. Now I have this. If I want to plot as a bar graph, I can just use the dot plot. You know, then I specify in here bar. So if I do bar and I plot, hmm, I have to do, I think, so I have to do kind equal to bar for that. So when you don't provide a particular parameter, it's gets confused, whether which one are you talking about, something like that. So this is it. So we have a bar chart, a very nice bar chart, and then we can see 2023, 2022, 2021, 2020. So it's like more in descending order from the first to from the biggest to the smallest, right? So probably maybe I don't like this. I want it to be from the smallest to the biggest because I want it is years. So I want it to start from 2020 and then go to 2021, 2022, 2023. So I want it to be the opposite. So if you want to do that, since it is we are lucky, it is like in descending order now. So if we kind of put it in ascending order, it means that it will be like kind of opposite. it will arrange like 2020, 21, 22, 23. Yeah. So to do that, to here, when we look at here, we can see that 2023 is the first, going down to 2020. To do that, we can sort the values in ascending order, right? So we sort the values using the sort values method. Now, so you have the particular data, you do dot sort values, and then when we run this, we can see that now we have it is changed, right? It has changed now. 2020 is current, so the smallest are top, and then the bigger are down, and then it's arranging year wise, year logic. It makes sense now because from 2020 we go to 21, 22, 23. So that's how we want it. So mind you, we've learned another thing. The dot sort the dot sort values method actually sorts the values. You have a lot of parameters here. You can look, more into that. But the one I would like to tell you is we have this thing called uh, the ascending parameter, and you can set it to true. When you set it to true, it will sort them in ascending order. But if you set it to false, it will sort it to descending order. Now it has a default value to be true. Even if you don't provide it, it's fine. It's going to, you know work. So that is why I didn't provide anything, but it worked. Another uh, argument there or parameter there is actually the sort by. When you have maybe more than two um, more than two columns or variables to sort, you can sort one column according to another column or something like that. So you use a sort by argument to do that. You can explore more when you go online. You just type um, pandas sort values documentation. You will know a lot about that. Yeah. So I've been able to sort, and we've seen how sort values actually work here. So now we actually going to first, instead of before we plot, let me clean this. So before we plot, we want to sort the values first. So after sorting, we get this, then we plot. And with plotting, if I do just plot, you see I get a line chart. Maybe I don't want that. We don't want that right now. I want a bar chart, which is bar, type equals to bar. Now you can see that now it has changed the other way around. So 2020, 21, 22, 23, something like that. Now, if I don't want a vertical bar graph like this and I want horizontal, I can set the kind to bar H. Bar H means that horizontal, so bar which is horizontal. And if I run, this is what I mean by horizontal bar charts. So you can see that it's kind of like it goes that way. Yeah. So if I set the kind to bar H, I get this. If I set the kind to bar, I get this. If I set it to pi, if I move what pin, I set it to pi, I get pie chart. If I set it to, you can think of them. Sorry. So I don't know who is doing me this, but I don't know why. Something is actually in my throat. In my throat, it's kind of pressing me. Maybe it's Jonathan, but I won't mind him. So sorry guys. I'm sorry about that. My bad. It's a bad thing, but then Jonathan keeps pressing my neck. You know. So give me a moment. So I'm back. Yeah. Jonathan, the devil is a liar. So I'm back. Um, so like I was just showing how you can change with just the dot plot. you can change a lot of things. So you can see here, when I change it to pi, I get pi. Let me change it to my bar again, and I get my vertical bar chart. Again, if you change it to bar h, you get horizontal bar chart. I don't want that. I want bar chart. So that's it. Now another way. Oh, let me even. Yeah. So now we've done this. Plot. Let's label the axis. The reason why here I'm using label the charts is that I realize the title isn't an axis, so it's not required where. So rather we say label charts or the charts. So if you want to label the x-axis as usual, we use the let me scroll before someone says Onim or he's doing up or is x label p to x label. So here it's gonna be here, and then let's label the y-axis as I always like frequency. Why? Because it's a frequency. Like frequency is the number of times it happens, and this frequency is actually count. So it is a count of the number of jobs in 2020, the number of jobs in 2020. Now if I run this, ooh, okay, I get this telling me that upload it has no. You know why? Because stop here. When I brought this back, I didn't run it. Right. So we got you. Right. Right. See, devil is a liar once again. Right. Yeah. That's it. So now let's label the title. It's always good you label your chat because it will help the other people to understand it. So this one, how do we label it? So jobs. How did I do the first time? I think I did the right way. So yeah, jobs per year, something like that. We do that and boom, we could go. Now you can see top here. I did one thing. PLT.grade. It's actually PLT.grade is just giving us the grade lines. So if I do PLT.grade for grade lines, we have some grid lines, the box. Now I did um, this POT dot x ticks rotation equals to 0. Now you can see that here the values of the x as the years are actually standing vertical like this. I don't actually want it that way. Um, that was Fozan, right? Fozan, I don't know when you muted yourself. It was really loud. I just unplugged my earpiece. I thought it was mine. You know, it's fine. It happens. So I was actually saying the x-axis is actually going to, when we say x-axis, it has to do with how the x-axis, whenever you call the x-axis, it has to do whenever you want to change anything on the x-axis, then you can actually use the x-axis. And then if you want to change anything on the y-axis, you use the y-axis. So I don't like the way the years are actually standing vertical like this. I want them to be horizontal, like so that it will be easy for me for my eyes. Yeah. So I'll just do plt dot xticks, and then I say rotation equal to 0. If I run this, oh, you can see that now they are not standing, they are lying, and they are sleeping, or they are horizontal. Yeah. Or if I set it to, let's see, let me do it that way so that when we do, if I set it to say, so it ranges from 0 to 360. It is rotation angles. So if you set it to 45, he's setting it to 45. You can see it is tilted like more like 45. So when you have the Cartesian plane, the XY plane, what the one we did in GHS and those GHS and primary school. So you have the XY plane, the XY plane. 45 degrees is actually dividing the first quadrant. This one, dividing this one to two equal parts. So it's more like to be a line straight through this. Is it? Oh, yeah, line straight through this, something like this. So the line, it will be more like this. So it will take that same angle. Now, if I change it to 90 degrees, then obviously you know where it's going to be. You see, so it was by default it was a 90. So it can be, you can assume any value between 0 to 360 was the complete circle is 360 degrees. So if you do, for example, 400, it will be like you're overriding it. But the whole idea is it ranges between 0 to 360. That is it. Now you can see I have some little, these extracts outputs here. I don't want that. So I always end my graphs with a semicolon, which is called a suppressor, to suppress those outputs so that I don't see them. I only see the plot. So that is what we did up here. But there is one thing I know some of you are very quick to ask. You can see that here, instead of me here, I did W, the WY, that is the work here dot sort values, just like here, work here dot sort values. Then I did plot, then I did kind equal to bar. But here I did plot dot bar. Then this is another way too. If I don't want to maybe use this way, when I do the plot, I would do so dot bar, so that I'm specifying that I want to plot, but I want to use the bar method, and it gives me the same thing. So if I do dot bar h, if I want horizontal bar chart, then I'll do plot dot bar h. When I get that, and if I do pi, I hope it works. I haven't tried it before. If it works, so dot plot, we can use probably a lot of things. So we get histogram too. We have a lot of things we can actually do. So in our case, we want always it is good to explore. We didn't get box plot isn't there, so it's good you try things out and then see which one works. So I've shown you two ways, any of them. I always want to show you more so that you become versatile, so that it's more like winning the away. Now, after plotting, let's make some meanings from this data or this chart. What do you see? The length of the bar represents the number of jobs in that particular year, not necessarily in the whole world, but in our data set. So it gives a picture of what is actually out there. Now, you can see that as the years increase, the bars also increase. What does this mean? What does this mean? Can anyone unmute his or her mic? If you can make some meanings from this chat, unmute yourself. Raise your hand. Let me call you. I will clap for you. In fact, I have some. And one more here. I'll give you the egg on it. Who who will do that? If you don't do, I'll call you. But wait, I hope you can hear me. Hope you can hear me, right? Okay,
The,
yeah.
the question again.
Okay. So Nanamwa, let my TA speak before. My TA is she's the one teaching me all these things. TA Fadila.
I just wanted to tell you to say the question again. I didn't get it.
Oh, okay. So the question is, we have this chart here on the screen, the one you see the bar chart, and you can see that very nice, very beautiful. And you can see that as the years increase, so from 2020 to 2021, the bar of 2021, the length of the bar is quite longer than the previous one. So 2021's bar is actually longer than 2020. 2022's bar is way higher than 2021 and that of 2020, and then same for 2023. So it's like as the years it will increase, as the years elapse, something like that. The bars also kind of increase. Now let me rename this probably so that we understand this thing better. Instead of making it frequency, let me make it um, number of jobs, something like that, so that we see. So these ones are actually number of jobs. So what I am saying, Jonathan, I'm coming. What I'm saying is that who can make some meaning? Can you get something from? Do you get some meaning from it? Now we have jobs per years, and we can see that as the years go by, the number of jobs increase. So we can make. I'm even saying the answer. So Jonathan, go ahead. Go ahead. Yeah.
Oh, okay. So like you just said, I just wanted to say that.
Say what?
Okay, so as the years increase, the number of jobs increases. So
Okay.
in 2000 it wasn't up to 1000, but in like 2022 it exceeded 1000, and then in 2023 it was it exceeded 6000. If I can see the visualization well, yes.
Yeah.
So
Oh wow, that's awesome. Thank you. My TA, she never disappoints me. My TA, the floor is yours.
So the way you started, don't let me say that, but I would say the number of jobs yes, is that proportion.
TA, your line is breaking. We can, get that you pump some sense in us, but unfortunately, your line is breaking. Jonathan is doing all this, right? He made me cough. He made my TA also cough. Now she is speaking. It's not coming. It's Jonathan. It's not anyone. It's Jonathan. Oh, yeah. TA, I'm back. I think it was from my network, something like that. So can you retake it? Yeah, TA, can you hear from me? Yeah, TA, can you hear from me?
Yes, I can.
Okay, so can you repeat what you were saying? I think I don't know what's happening. I'm just going off and off.